Okay, so here's the function, right? That's the function that you guys were working with. And what was the meaning of this function? So can you state in words what the meaning of this function is? Explain it. Yeah. Huh? The expected attendance in thousands when the temperature is T in degrees Fahrenheit. Okay, good. Okay, so if I were to do this, now I say I want to, so that's the function. So does it graph it? If I just put that in, does it graph it?
No.
Why not?
Because you need to define it as in like with y equals, or like define which one's gonna be your y value.
Okay, right. So does function, is it equivalent to a graph?
No.
So what's the relationship between a function and a graph? What's that relationship? Okay, but that's not what I'm asking. I'm asking what's the relationship between a function and a graph? Right. So a graph is one representation of a function, right? There's other ways to represent a function. And there's other uses of a function that have nothing to do with a graph. So a graph is one way to represent a function. So by defining a function, there's nothing inherent about that is equivalent to graphing. So I think that's good because GC agrees with that, right? GC putting in the function doesn't graph it. So instead we tell GC to graph by doing what? Y equals. Okay, so I'm going to do y equals a of t. Is this going to work? It's going to show me the graph of function a. No, don't try it to answer. Fingers down, fingers down. Is this going to do it? What do you think? Why not? You need an x. So what would this do? So if I hit graph, so I can click on graph. What's this going to do? So the horizontal line will be at the value of t?
Yeah, whatever t is predefined.
Well, so variables are by default are 1. Do you remember that?
Yeah.
So it's going to be y equals 1?
Yeah.
Agree with that? Y equals 1? That's what you're going to get? Lydia, what do you think? That's what you agree with that? Yeah, it's going to be a of 1, right? It's not going to be y equals 1. It's going to be y equals a of 1, which is what the expected attendance when the temperature is 1 degree. Which is, I think it's outside the domain, but okay. So what is that going to be? Something like 13. So we expect a line around y equals 13. Not quite enough. Oh, I'm zooming the wrong way. What am I doing? Still not? Come on. Come on. There we go. I can't read those numbers too small. Okay. Yeah, so about y equals 13. So instead, if I want to graph this function, I need x, because an x and y in GC are like a spray of all the values and then on the graph, right? So it's prompting GC to graph for all x values and all subsequent y's, right? So it's going to graph y equals a of x. And then you guys figured out how to get a good view of that. It's not bad. But then there was a domain issue, right? So we don't want all the points for all x values. Which x values do we want to show the points for? 0 to 110? So what does this say? It says, okay, well, I want you to graph that relationship, but only for the points whose x values are between 0 and 110, right? I see it still if I zoom in once. Okay, pretty good. Okay, and so now we want to plot a point on that graph, say for temperature of 35 degrees, how would I do that? Lydia, how am I going to graph a point for corresponding to 35 degrees? Control 2, good. 35. A of 35. And what's the advantage to doing A of 35? Okay, it's exact. What else? It's exact. There's another advantage. Or there may be lots more, but you don't have to do anything. It knows, right? You got the relationship. Let GC do the work, right? So A of 35, remember we talked about this before. At the baseline level, it doesn't mean to do something. It stands for a value, right? It stands for the value. What value does it stand for, Jason? A of 35.
For the expected attendance for the temperature is 35.
Well said. Very well said. All right, and so there it is. So did I just add a point to the graph? I just added a point to the graph. Highlighted, right? It was already there. This is all points, right? This is a zillion points that are already there. So now we're just kind of highlighting or emphasizing a particular point that was already there. Okay, so now let's make the triangle here. So let's make the little calculus triangle here. I want to show a variation in temperature of 10 degrees. Let's say 12. I want to show a variation in temperature of 12 degrees. And then I want to show the resulting variation in attendance. So I want to, just for this particular at 35 degrees, I want to show that. So, Alyssa, how can I show the variation starting from 35, variation of temperature of 12 degrees? So A of n. I just want it for this, right, for temperature 35. Yeah, 35. So 12 degrees. Percent. That's good. We'll get there. It's all right. I'm mixing it up on you. Okay. How'd she do? It's gonna show. What's this gonna show? Does it show what I said, Veronica? So I want to show, starting from 35 degrees, I want to show the display a variation in temperature of 12 degrees. I think that'll do it. Yeah? Winston agrees? You guys agree? Okay, now I want to show the corresponding change or variation in attendance for that variation in temperature. Let's give it a shot. What will I put in? Let's see, you want to try that?
What was the variation?
So I want to show the corresponding variation in temperature to this variation in, corresponding variation in attendance for this variation in temperature.
Would it be x equals would it be a of 35 plus 10?
So what points do you want? X equals what, right? X equals
35 or 47?
47 from
A of 35 to x to 59. Or A of 35 plus 12.
inside?
Yeah.
Okay, what you do? Agree? Jason agrees? Lydia? Is it going to show correctly when I graph this? Why not?
Needs to be y in the middle. Oh,
You good? Yeah, so then we're restricting the y values, not this time. Now we good? I think so. Okay, now what about, so so that was, you guys did well, really well. And so did we do well because there was no variable, no n involved, or because you just did the assignment? Was it so, okay, thanks, that's honest. So when we get n involved, from just this static situation where it's all values, when you get n involved, was it harder? So can you put into words why that becomes harder? Yeah. So is there a way to think about it that makes it not so hard? Because it's really the exact same thing as this, right? Except what are we doing? What's the difference between this and then the movable triangle? What are you varying? Well, that's just like what you see. What is different in the math? Yeah. Right. Okay. So what is different about the n case than here? Okay. For what? No. You just use that variable n for one thing, and everything else falls in, right? What to use the variable n for? Which temperature?
For any temperature on the graph, because
Which there's really only one change that you have to make.
oh, you make 35 into n.
You make 35 in n. Yeah, you want, so this key point, or here's the key starting point, right? So now if we want to vary all of this, we're gonna reference this x coordinate of that point. So we want to start at what? So n is going to be our x value, right? And then everything else is the same. It's not different than what we just did. It's just that if you make n that initial value, then you'll be able to change n. But everything else is the same. So it'll be a of n, and then n, 2, n plus 12. And then this is going to be x equals n plus 12. Y goes from n to. So there was only one little difference, just that 35, right? Yeah, the 47 you had to conceive it as 35 plus 12. But it's really just all it's a matter of is changing the 35 to an n. And now we can vary n, and it's going to give us. I got to change this, so my range is what? 0 to 110? So I'm attempting to show you that it shouldn't. I know that it is, and that's okay. It is some more difficult, but it shouldn't be, right? It's how you imagine n. N now just becomes any starting x value, and then you do the exact same thing that you did with the numbers. So I would love to do a little research, do interviews and get into your heads in terms of where that trips you up, because I know it does. It's okay. It's okay. That's why we're working on it. Okay. All right. So then what happens? We got this far. So then when you get over here, boom, it disappears. This is the last part. So what's happening? What's going on? Did you figure out what's going on here? Okay.
It's only going upwards.
Okay.
Now that the horizontal line is above the curve, it's no longer defined.
Okay. What do you think? Did you hear what he said? Agree with that?
The vertical line positive change in attendance, and
Okay.
it once it gets to like 73, which is its max,
Okay.
it's not able to like keep saying we're gonna go up.
Okay.
There's no decline for it, so we have to put.
Okay. Yeah. You're onto it. Definitely. So this let's look at something here. So this statement is really a combination of two statements. It's y is greater than a of n, and also y is less than. It's both of these, right? It's all y values that meet both of those conditions. Would you agree? So just kind of as a, I'm going to turn this one off. So that, I'll turn them both off. When I turn on this y is greater than a of n, what's going to happen? What are you going to see? I'm going to turn that on. Y is greater than a of n. What will graph? What will GC graph if I do y is greater than a of n? First of all, whenever we declare our math statement to graph, what is the thing that always happens? What is graphing in GC? It's always displaying points, right? So every math line that it's going to graph some set of points, either one point or a set of points. So that's the way we got to think about this. So what set of points is that? What set of points is that? And it's going to illuminate all of those points. What do you think? Have an idea? It's all the points such that what? Right. Where are those? So what are all the points such as y is greater than a of n? The whole region above the curve.
Oh wait, I did this kind of. It like shades it in, doesn't it? Or something like that.
So she's saying the whole region above the curve. Agree with that?
Wouldn't it just be a line because n is a single point? Or would it just be a line upwards?
A line upwards, because n is a single point. Lydia, what do you think? You didn't do it, did you? On the computer, did you? You're looking at your screen.
No.
Okay. I'm not going to change n. I'm just going to leave n at whatever it is, 96.8 or 98.8, whatever it is. I'm not going to change n. So if you're not sure, what questions can we ask to start getting sure? So we can kind of like take this one element at a time. So what question could we ask first?
So A of n
Mhm.
basically.
A of n, what's that?
It's expected attendance given any temperature between 0 to 110 in this case.
Is that right? That's what A of n is? It's all the expected attendance from 0 to 110? Veronica, what is A of n? Okay. What is A of n and how would that graph?
A of n is the expected attendance when n equals a certain value.
Mhm.
In this case, it equals 96.8.
Right.
So it's going to be the y values for A of n that are greater than A of 96.8.
So all the points whose y values are greater than A of 96.8. Agree? So what are all the points whose y values are greater than A of 96.8? the little segment? So he's saying it's every point above the horizontal segment. Like,
Including all the x, like it's just gonna like a shade of.
so you're saying it's going to extend horizontally, not just be above not just above the segment, but extend horizontally above the segment. What do you think? A of n is a y value, right? What if it was y equals that y value? What if it had equals? What would you say?
It'd be that line extended.
If that segment extended horizontally for all x. Now we're saying y greater than that. What color? Blue. Okay, now what about the next one? Y is less than a of n plus 12. What's that going to look like? Where is that? Where's the line of a of n plus 12? Is it at the bottom of the blue? Where's the line of a of n plus 12? Okay, so then where will that line fall? It's going to overlap, so it's what I hear you saying is that a of n plus 12 is like up here, but then it's going to be all the points down from there. You guys agree? A of n plus 12? You agree?
Yeah, since it's left hand, so it'd be below 7.
Okay. You agree with the a of n plus 12 being a line up here?
Yeah. Well, it'll
Right, but the a of n plus 12, it's a line up here.
Yeah.
So here's a of n is this y value, so where's a of n plus 12? Higher or lower? Lower, right? Isn't a of n plus 12 here? So what's it going to look like when I turn this on? It's going to be a gap, right? And this is the reason why nothing graphs in this thing up here. Because this is saying all the y values greater than a of n and less than a of n plus 12. What y values are those? There aren't any, right? There aren't any y values that are above a of n, that's the blue region, and below a of n plus 12, that's the green region. So since there's no points that satisfies that, what does it say? Undefined. It's undefined means I'm not going to plot you any points because there are no points that satisfy that. And when you look at that green shaded, the very trendy, cool looking green, what are you looking at? All the points whose y values are less than a, right? Yeah, so it's so that you're not looking at specifically y values, but points that have x and y values, right? But it's the y values. You're right. That's the y values that define which points we're picking. Okay, so the remedy is. But what's the remedy?
We should just switch the range interval or something. Like a of n would go where a of n plus 12 is.
Okay. And why is that, Jason?
To represent negative change in attendance.
Okay. Why did it have to switch those? Can you say it in your own words. That's going to do it now. why does that work? Why does this work? Because well, how do these values compare? How does a of n plus 12 compare to a of n? It's less. And why is it less? Because the function is decreasing, right? If the function is decreasing, then function values later down the road are going to be less than. And so now we have all y values, what? Greater than the lower value and less than the higher value. Well, now you've got a set of points, right? Now you've got an actual set of points between those two. But now that one's going to be undefined, what? When we go back before whatever, 73? Now that's undefined, right? Because there's no y values greater than a of n plus 12 and less than a of n. Okay, any questions on this assignment? So we're going to have our first, we have like 5 or 6, what I call them assessments in this class. And they're like long quizzes. I wouldn't call them a test, but I wouldn't call them a quiz. So we're going to have the first one on Thursday. And it is on all the stuff that we've done so far in GC. So points, sliders, function notation, graphs, all the stuff that we've been working on. If you want more practice, I'm not going to sign it for homework, but I think it's in here. Yeah, this sunflower graph activity, so it has text lines that kind of explain and questions, what you're supposed to do, and then blank math lines. I think we saw that with we did the box cause problem. We've seen something like that before, right? Where I intersperse math lines with questions and tasks for you to do. So that sunflower graph is really good practice of all this stuff and good practice for the assessment next week. It's written. Yeah, it's a piece of paper, but it's GC is integral in it. You need to. No, you just can write stuff out. So again, that's good practice. Okay, let's look at this. Any questions? Now that's not so that getting ready for the assessment is one of maybe 2 things I'll have you do over the weekend. So there will be additional homework. Okay, so let's talk about this scenario here. And I've defined this letter Z as used smartphone memory space in gigabytes. Now you can tell that I made this little thing maybe 3 or 4 years ago. Why? What's that? Oh, well, no, that's not what I'm saying. You haven't seen what this can do yet.
2 gigabytes of memory space.
Right, so
you got 10 gigabytes.
Is that a lot on smartphone? That's not a lot at all. What's standard? What's standard on a smartphone these days?
It's like 60 to like 256.
I thought it was like RAM.
It was like 32,
I was like, that's fine.
64.
So I'm gonna have to if I did 50 or 100, that'd be more realistic. Okay, so I need to change
Just say this is RAM and then you're fine.
RAM.
Yeah.
Well, no, in terms
2
of
gigs of RAM is still pretty normal.
well, it doesn't really work when you see what this is representing. That doesn't really work. It needs to be like hard drive space. Okay. So anyway, just pretend this is a realistic situation that 10 gigabytes is plenty. It's all you need. Okay. So Z equals U smartphone memory space. Is it a variable or a parameter? Why variable, Veronica? Yeah, right. So it's changed dynamic. So Z is a variable, and I'm showing 2 bars here, right? And so we saw in the class on Tuesday in the in-class activity. I also had a graph that was showing bars, right? Variable bars. So looking at these 2 bars, the red bar and the blue bar, what might those bars represent? So there might be more than one realistic answer, but maybe in our discussion we can land on what I intended, but there could be other possibilities. So what are some thoughts that you have? What are the red and blue bars representing here?
Do they represent what each, like being in your
Okay, sure, that's possible. So what about in the context of how I've defined Z? So I defined Z as your used smartphone memory space. So what might be something to do with Z, what these represent? Any idea? What's that? The red one represents Z? The red plus the blue is Z. That's possible. Could just the red be Z? Yeah, so either way, yeah. So maybe the red plus the blue is Z, showing all you're up to 2 right now. Or maybe just the red is Z. Okay, if just the red were Z, then what might the blue be? Okay. All right, blue could be free. What could blue be? Yes, and in fact, my intention is that the red is Z.
Blue could be like something you're trying to download.
Okay. And so what would that in what we've been talking about so far this semester?
So it would be like
Trying to download. So you're using up Z right now.
it would be like the amount of Z used if you. It would be like a future amount of Z.
The blue would be the future amount of Z.
The blue would be like Z that you're adding on.
The Z you're adding on. What do we call that? A change, right? A variation, right? So it's like, and how do we label that? Do we have a label for a variation in a variable? Okay, so we're gonna use DZ. So now it's a little bit. There we go. I'll do that so you can see a little better. So this was my intention. We landed there. That's good. And so your other suggestions were possible. Lots of them could also be possible. But this was what I was getting at. That the red bar shows your used smartphone space, and then DZ would be like you're gonna download an app, and so it'd be your variation in Z. And then what happens? In the end, you download it, and in the end, you have a new Z, right? You have a new Z, because Z had changed. Z varied from the initial amount to now a final amount after you downloaded. Yeah, okay, so I have some real simple worksheet, but I think this is good. Everyone go? All right, so this is pretty elementary, pretty simple, but what we found is like that our calculus students. So before you start writing, don't write and read. Just listen. So what we found that is our calculus students, the idea of Z varying through many quantities, that's kind of foreign to them. What's even more foreign is this idea of a variation in a variable. That can start anywhere, right? That could start at Z of 1.5, that could start at Z of 5, and then the amount of variation, the amount of change being dz, this is really foreign, okay? So variables varying, that's not really covered in high school traditional math, and so that's a challenge in itself, but then dz is like whoa, totally foreign. So this exercise was to help to get the feel between what is Z, what is dz, how are they related to each other, okay? So in each scenario, you're gonna assign or find the value of the initial, Zi, you're gonna find the value of Z final, and the variation. And 2 of those are always given and 1 is unknown, okay? So you're given the information, you're gonna write down the 2 that are given, then you're gonna figure out what the unknown one is, and then based on what you did, you're gonna write a formula that computes what you did in your head. You're gonna formalize that in a formula. How did you compute the unknown? Okay, so
You want the formula with the values or with like Z?
no, with the variables, with the symbols. Okay, so if it's really easy, good. It's not supposed to be hard, but it is supposed to really. Okay, so from number 1, what did you find as a formula for number 1? Is that a hand, Veronica? Sure. D? These are Z's, right? Yeah, so these are values of Z. So is this what you said? Agree with that? So yeah, and so let's what we really so often if we're gonna write it this way. Is that what everyone got? That's what you should have done in your brain to get that amount of the size, basically the size of the app, or the variation in Z, right? That's the variation in Z. And then number 2, this one that I'm showing, what formula did you come up with? What's the unknown? ZF. And how do we get ZF? Agree with that, Jason? ZI plus DZ? I heard minus. You want? She said plus. Yeah. Okay, so not only should we know these formulas, but they should make perfect sense, right? Like if you're thinking about what the symbols mean rather than just reading it verbatim. So why does DZ equals Z final minus Z initial? Why does that make sense? Instead of just being a formula we memorize and okay, this is how we calculate it. So why does it make sense that DZ is Z final minus Z initial? Melissa, can you express that?
See how much you've changed. You have to take like an ending value, subtracting your initial to see how much.
Yeah. Absolutely. That's one meaning of a difference, right? One meaning of a difference is how much variation you had from the starting to the ending, right? Or how much is in between. Okay, and then why does the second one make perfect sense? Z final equals Z initial plus DZ. Like this, to me, this is even easier, right? Why does this make sense? Can you articulate that? Melissa, can you say?
Because we're starting from 4.4 and to get to that space at 7.9, there's some change that needs to happen. Then we can see that from DZ.
Right. So you have an initial value, and you're going to add how much variation you have to that, and then that's going to give you the final value. It's going to be perfect sense, right? Okay, but so these two very simple things we're going to see in about 3 or 4 weeks. These are like the 2 main underlying principles of calculus. They're like 2 sides of a coin, and these are like underlying principles of calculus. So we're going to build that up and see why that is. Okay, so what? There was a question that the activity had you work through 3 of these and then ask the question, what's the difference between a value of Z and a value of DZ? That was the whole point of this, was for students who never been exposed to variables varying and then the actual variable of a change in a variable. How would you articulate what's the difference between Z and DZ? Okay. Yeah. So Z is any value of the variable, and then DZ is a change from one value to another, right? Or how much variation. Okay. So if you want to do part 2 on your so now let me show you a different way to look at this. So here's I've been showing you this. Now check out this way. This is kind of a different way to look at this. Where's that? View number 1 maybe. Ready, and go. How about this? So I changed the view here, and now I'm showing this. So this was exhibit B, and this was exhibit A. What's the difference? What is the new one showing? How is it showing it differently? But not just like what's different about it. Well, here the blue bar is just there, and then here the blue bar is growing. No, that's not what I'm asking. I'm asking what is it representing? How is it representing something different? Talk about meaning. Versus this. Okay. Right. It's the change in Z as Z is changing. So what does that imply about dz in this case? That it wasn't implied in the first one. It's a variable. See that? Yeah. So this is showing the same scenario, but that dz is varying along with z. And this is the image we want to have of dz as we develop calculus rather than this one. So here dz is more like what kind of thing? What do we call it? Parameter, right? And so now in this take on it, dz is shown as a variable. It itself, the amount of variation, changes as z changes. Right? What's more realistic? What's more in the context here of a smartphone? Why? Why think?
You don't just download a whole thing of memory all at once.
Uh-huh.
You just use it up continuously as it downloads.
Uh-huh. Right, so as it's downloading, your variation is growing, right? Your variation is growing as it's doing it. Is there any way to view this as more realistic? So maybe this is more realistic if we just look at this and don't vary z. How can we think of this now? Maybe both z and dz are kind of like parameters, right?
Yeah.
What situation would this be? Yeah, like you're checking it out. You're checking out the app, and you want to know what it's gonna be like, right? You know you're at 4.5 gig, and this is displaying. Okay, when I'm done, this is how much it's gonna change. Okay, cool. All right, so that's. Go ahead. What's that? 4.5. Okay. Or a movie. Sorry, a video. How about a video? Okay, sorry, a video. I should have said a video. Missing the point, Veronica. That's okay. Just kidding. All right, so let's look at this. What do we say the change, given a variable x, the change in x or dx is? What do we say? Hello? Final value of x minus initial value of x. And then given a variable y, we could say the final value of y is? Initial value plus the change, okay? So this, like I said, these are going to be two essential principles in calculus, and we'll see these showing up over and over again. Okay, so we've said that dy is computed as, so we could say that dy is computed as y final minus y initial. But if y changes along with x in some relationship, dy can be determined in a different way using dx. How can dy, what is it? And what does that imply? You said dy equals mdx. What does that imply? Constant rate of change, right? All right, so what's the meaning of 70 miles per hour? I think we talked about this the first day, maybe a little bit. Yes, tell me.
Any variation of dx, dy is going to be 70 times the change.
Okay, good. Can you talk about the speed and the units?
Okay, so for every
You can do it.
Is dy going to be defined like the distance, total distance traveled?
That would be like y. So what would dy be? Just like the worksheet, right? If y is the total distance traveled, then what is dy?
Variation.
A variation in distance, right? Yep.
So in variation in time, the variation in distance traveled is going to be 70 times variation in time.
Right, very good. What do most people say to answer this question? The meaning of 70 miles per hour. You go 70 miles, every additional hour means you're going to go 70 more miles. All right? But that's narrow, right? That's narrow because we know how far you go in 2 hours. Quick, what is it? 140. We know how far you go in 5 hours. Half an hour. In a tenth of an hour. 7. We know all those things. In fact, we know what additional distance or variation in distance for any variation in time. So for any change in time, the change in distance is 70 times that change in time. If, that's only if what? I can only say that if what? What's the important qualification here? Yeah, we're on cruise control, right? 70 miles per hour is cruise control. Our speed is not varying, okay? Then we can say that for any change in time. The change in distance is 70 times that change in time. Okay? Oh, you want to see it again? Thank you. All right, this is a technology course, right? Okay, so constant rate of change. Here we go. You're filling up your gas tank. Gas costs $2 per gallon. What's the meaning? I think we did one like this on the first day. What's the meaning of $2 per gallon? The constant rate. Who wants to? What does that mean, Lydia? Okay. Almost. You said the cost will be 2 times that additional amount of gas. Yeah, your increase in cost, right? Your variation in cost will be 2 times whatever variation in gallons you did. Okay. Any change in number of gallons, the change in cost is 2 times that number of gallons. Okay, so here's an example. A store sells make your own snack mix gifts. The box costs B dollars, and the snack mix costs $2.75 per pound, which means tell the person next to you. So everyone, take turns. What does it mean that the snack mix costs $2.75 per pound? Go. Okay, Jason, you're up. Tell me. I'm going to get good at this. No, we're going to get good at it.
So, for any additional cost in pounds, so for any variation in cost, it is so variation in cost is $2.75 times the change in pounds plus
Okay, well this is just asking about the snack mix costs $2.75 a pound, first of all. So it's not asking about the B. It's just asking about this. Okay, so what is the meaning of that? So what comes first? Does the variation in pounds comes first, or the variation in cost come first? That comes first.
Well, isn't that
So you're buying snack mix and you say, I want $3 more, and then you have to figure out how many pounds that is. Is that no? How's it work? What comes first?
like how much I want?
Right. So for any variation in
In pounds.
yeah, so if you have dollars per pound, what is your change in Y and what is your change in X, or your change in dependent? What's the dependent and what's the independent variable?
Or independent variable would be pounds.
Right.
And then
Independent?
dependent is the cost.
Right. So for any change in
Pounds.
pounds, call it W for weight.
The change in cost
The change in cost.
will be $2.75 times that.
Right. So just think about like how if you buy 10 pounds, 10 more pounds, how much more do you pay? What do you do?
Multiplied by 275.
Multiply it by 275. And if you want one more pound, how much will you pay? 275, right? So that's where this comes from, right? However many more pounds you buy, you just multiply by 275. That tells you how much your cost goes up. Why isn't B in this? Does it still work that the cost of the box is B? Why does it? Is that still true? Why is that true?
It's still true because that's kind of like the constant in the situation.
Right?
There's always going to be that cost of the B. You just add that on, but it's not going to be affecting the
Do I need to add it on here? Do I need to add on B here?
Oh no,
Not
isn't
for the
that
change.
That's what, because this is about what?
change?
Variation, right? How much cost changes. This doesn't have anything to do with B, right? How much it changes for an increase in pounds has nothing to do with B. So this works perfectly fine, and it shouldn't have B in it. Now, what has B in it? The cost, right? What is the cost? Hmm.
2.75 times the change in weight, or times the final weight.
Yeah, times all the weight, right?
Plus
Yeah. Okay, but we don't, that's less important right now. So that's important, but that's less important right now. But so yeah, so your whole cost would be 275 times your whole weight plus B. Does it see the difference between? So again, difference between W and DW and C and DC, right? The variables themselves and the variations in those variables. Okay, so define each. So one thing that we really try to stress in conceptual orientation is when you have a situation, really understanding and modeling the situation, as opposed to what's when you have like a word problem or a real world context. What is often the strategy that or the behavior that students exhibit? What do they do? Yeah, look for the numbers, look for a formula, and try to get an answer, right? Rather than that, we want to emphasize in a conceptual approach, let's understand the situation. Let's like really make sure we understand it, and let's model it mathematically before we do any calculations. So we're going to model the situation with variables and parameters. Okay? So we're going to find each variable below completely this precisely. What is x? Variation in weight or total weight? Total weight, right? Or number of pounds. Y is total cost of x pounds. What would dx be? What would that represent? A variation in pounds, right? A change in the number of pounds or additional pounds, okay? And dy, a change in the cost. M is 2.75. Write an equation using these variables that computes the constant rate of change. What would compute M? How would you write something that would compute M? Okay, yep, that's true. But if we wanted to actually compute M, like we want to say M equals something. She wants dy over dx. What do you think? Yep. If you knew some variation in cost and some corresponding variation in pounds, considering its constant rate of change, that ratio or that quotient would give you that 2.75. Okay, what about? Okay. Write an equation using these variables that computes the change in cost for a change in the number of pounds bought. Beat this to death. What's this? What computes the change in cost? dy equals mdx, right? dy equals 2. I could have written 2.75. Absolutely, that's right. Dx. Okay. All right. So I think we're good here. Let's. I want to start working on something else in Canvas. If you go to Canvas in that GC files, I moved that GC files up right below class videos. If you pull out, we pull out laptop battery charge activity. Let's see, I'll move it to the top. So it's the first one. First one on the list, laptop battery charge activity. Are you able to find it? And there a bunch of blank lines and is this what it looks like? Okay, so this is supposed to be blank there. Okay, so suppose you open your laptop during class to take notes. 35 minutes after class started, your laptop battery had a 41% charge. Then 75 minutes after class started, the battery had a 28% charge. Okay, the percentage charge P dependent changes at a constant rate with respect to the number of minutes since class began. So what we want to do is, so we got our dependent and independent variables, and normally we graph x. Which variable do we graph on the x-axis? They're saying independent. Agree with that? Normally independent is on x and dependent is on y. So that being said, so I want you to display these, and you display as percent, not the decimal version. So just go ahead and display values as percents of charge. So you're going to use these first two to display those 2 points. Parameter.
Oh, M is equal to.
Yeah, we want M, we want GC. Okay. Was that already there? Yeah, the slider. So erase that and I'll show you how to put that in. Negative 35 to 55. Okay, so all right, so now using the variable dx of the slider, let the slider range from negative 35 to 55. So first of all, dx, GC does not know what dx is. It would think that's value 1, and then x is like you want to graph something. It doesn't know what dx is. So do you remember how we can turn a character string into a parameter or variable. Remember that? What to do? Backslashes, right? So you're going to do backslash right above a return, and then dx, and then backslash again, and then the backslashes go away, and now dx is a unit, right? It's together, and it's like capital T or B or A. It's just like it's a single variable. So then we're going to make a new slider rather than using n. So we're going to say equals slider. So we just equals, and then when you hit, it should be unitalicized. And then you want starting value. What did I say? Negative 55? Negative 35 to 55? What's that? No, it's not a function. You can do shift 9 is fine. This isn't a function. This is a built-in operation in GC. So now, and then you see here that you've got your little, you don't have a play button, but you can manually change the value of dx here by grabbing on the button and moving it, and it shows you what the current value of dx is. And so then in other command lines, we're going to use dx, and it's going to use dx at whatever its current value is on this line in the slider. Make sense? It's just there's no, when you do these manual sliders, there's no play button. You have to grab it and move it. Okay, so that's the setup. Now using the dx variable and m parameter, right? So dx is a variable, m is a parameter. You're going to recreate this for homework. So what is this animation showing first? What am I showing in this animation?
Constant rate. Oh, well, that's what the triangle represents.
What's the triangle represent?
The rate at which the battery is going.
Does the triangle represent the rate? I suppose maybe the proportion, the size proportion of that. But these scales could be off, right? So if the scales weren't the same, then that would, it could be totally skewed. So similar to your attendance battery problem, or attendance temperature problem, what does that triangle represent? What does that represent? Okay, so specifically what change, right? So specifically what change? Which is it? Is it a change in time or a change in percent charge? Which do you think it is? Is it showing percent change in time or charge? What's that? Both, right? And which particular change is it showing? A variation in time, what? Right, from 35 minutes after class started, right? It's showing some variation in time from the 35-minute mark, and it's also showing well, so for any given variation in time, that's what, the horizontal or vertical? That's the horizontal. For any variation in time from 35 minutes, that's the horizontal. It shows the, which is shown by the vertical. The corresponding battery variation shown by the vertical. Okay, so the way that you're going to build this triangle is different, right? What is dx? Dx is the amount of change. Okay, so the way that you build this triangle is kind of a different approach than what you had in the attendance temperature problem. Okay, so that's going to be in the video, and you're going to finish this and get ready for your assessment on Tuesday. That's your homework for the